Nick, we are in the area of the factory now that they're responsible for producing the A-series doors. If you look at these components, they're ordering these as is and then milling them from here. So a big thing to note with the A-series, their availability to make the biggest doors other than their actual big doors, right?
Yeah,
so they're getting,
product, right?
yeah, they're getting bigger. They're more energy efficient. If you look at these materials, we have a maple, an oak, a paint grade, and the stock for these is made out of LVL. So there's a few reasons that they're gonna go with LVL versus another product. As you get bigger, it's gonna be straighter, it's gonna be more stable, the tolerances are gonna be tighter, and it's also gonna be more energy efficient, and just with the density of the materials.
The core is really important from the stability and the strength, as well as the energy efficiency. But then you have this veneer layer on either side, and what that is for is to protect the wood, but also give a really smooth finish for paint grade. And then as you work your way down, you do have a maple core, but you're gonna notice that on the back side, you still have this, because this is gonna be what your exterior coating is applied to, and this is likely gonna be unfinished or some sort of finish interior, maybe a stain or a clear coat. This is how they're getting that material, and then it's going into the mill process. Very similar to how they are milling their window components. I know our clients, and I'm sure your clients, they're always demanding more and more glass. How can I reduce the rail and style on the door? And one of the ways to do that is by using a quality material like a LVL. Why don't we hop down to the milling process? Just like the window shop, all of this material comes in and goes on this first, and this is where everything is going to be cut to length per order. And they're going to be batching this stuff to go into a supermarket in standardized lengths.
This is the same process as what we saw with the windows and the milling. They're creating the molder blades and the shaper blades to cut this to the unique parts that they need. The doors are using the LVL material. That's the only difference between this process and what we saw downstairs.
So as that raw material makes its way through the saw and the molder, this is where it's going to come out and then work its way down the assembly line and then prep for finish, because these parts are finished prior to assembly.
They're going to come out of this molder essentially with whatever type of joinery the door series requires, as well as the shape and the profile.
And the benefit of using an A-series is you're going to get a drill and dowel corner, which is significantly stronger. So we're going to loop around. There's some finished parts on the other side, and we can actually show you what that looks like prior to assembly. A lot of the other series will have a Mortise and Tenon connection, which essentially is all manufactured within this one piece of lumber.
Yeah, so I believe they said it's going to help with rotational force, especially when you have wind loads, which I found very interesting because I'm thinking traditional joinery, and typically a dowel joint, even with cabinet building, is a lower grade joint. But they did the engineering to test that the dowel joinery is actually stronger than a traditional mortise and tenon joinery, which I find interesting.
Yeah, so this here right, is a small rail. It's actually the smallest one they make, and the dowels are already pre-installed and glued into this. And then behind us, we actually have the stiles, which would be the vertical piece of the door, where these are the horizontal. And this, when it gets to the assembly table, these are going to be glued and then placed into that stile, creating that really, really strong corner, outside corner.
The glazing is going to sit in here, so they have a gasket or a weather stripping here for that joinery, and they also have, looks like with a brush, pre-primed any of that raw LVL material, so that this is a waterproof connection. If any water at some point were to wick into that joint, you have this gasket as a fail-safe there.
So by adding that gasket and making sure that that is finished beyond there, you're basically prolonging the life. You see the parts. Now we're gonna go over to the assembly table and where all of this stuff comes together.
You can see here that he's loading the door components into this machine, into this form. So he has the side stiles in right now. He's dropping the upper rail in, the lower rail. You can see those dowels. And then I would assume a glue machine's gonna come in and glue those joints up. Yep, dropping wood glue into the dowel joints. Here he's gonna squeeze the whole unit together and apply pressure onto the joint. Then they're nailing that off through the top and bottom rails. so that they can release the pressure on those clamps. Prior to fully curing, it's not going to create strength other than keeping that glue joint tight until the glue is fully cured.
And this is a great viewpoint too, where you can see that everything on the exterior is all finished, even to the hinge point, but then you can see that clear transition from where the glass is going to sit to inside of this door, which is, in this case, it's a clear white pine. After everything is assembled, it works its way down the assembly line. You can actually see he's got this overhead suction cup. This is something that you're going to see pretty much in any really big manufacturing facility, is these overhead cranes, but this specifically designed to lift glass. You know, alternatively, you would need two guys to pick up that piece of glass and then bring it over into the table, and then it's a matter of kind of situating your hands to get that installed in the door. This makes it quick, painless, easy. They pick up that panel is dropped into the door with an applied silicone, and then now that glass is essentially finished from the outside, and then it continues down the line where they're going to add their stops and all of the interior sealants and essentially finalize that door panel prior to installing it into a jamb and hardware.
So you can see he's cutting the stop right here. This is going to be the finish on the interior of that door. They're going to all get dry fit and then pinned in place. And then that door is going to move down. After they apply those stops, they're going in and siliconing the exterior glazing for waterproofing and to seal that joint up.
So the final piece for that panel is they're going to put this one-piece weather stripping. So it's continuous all the way around, corners are welded, very similar to the windows. You know, this used to be a 4-piece gasket, now it's completely monolithic all the way around the door, and really helps with those trouble areas, which are going to be those corners. When that door is shut, you want to make sure that you don't have any air or water intrusion. This, along with the bottom gaskets that they're installing now, are going to be what helps prevent any water and air from migrating into your finished home. So as the panels are put together, they're all staged here on a cart, and then they go into the panel prep and assembly area, essentially hanging the doors in the jambs.
As far as getting in the frame, that's all pretty much straightforward, but we really wanted to show you how these door units come together. We didn't show you any of the sash assembly with the windows, so we really wanted to focus on that here.
And with that being said, like, you can take our word for it that this is stronger, but in a future video, we're actually going to test some of these panels. And I think we're going to do it with a Canon.
I know we're going to do it with the Canon.
So stay tuned for that video where we're going to test some of these panels and show you just how strong some of this stuff really is.